Hello guys, and welcome to my YouTube channel. Today we are going to tackle an ordinary differential equation problem. Our problem today is dx1 over dt equals to 5x1 minus 2x2 and dx2 over dt equals to 4x1 minus x2. So this is equation 1 and this one over here is equation 2. So the question is solve the following system using elimination method. Elimination method. Okay, so how do you go about this, guys? So given such a question, the solution can be obtained using the following steps. So step 1, we differentiate equation 1. How do we do that? So differentiation of equation 1 is simply d squared of x1 over dt squared equals to 5 dx1 over dt, right? Minus 2 dx2 over dt, correct? This will be our equation 3, right? The next step after this, step 1, would be to substitute equation 2 into equation 3. What will we have there? So we'll be having something like this: dt squared equals to 5 dx1 over dt, correct? Yes, minus 2. Now substituting equation 2, we'll take this and put it in place of this. I think we are saying this, guys. This will be this. This will be this. I hope you're saying that right. So with that in mind, we come and write here for x1 minus x squared, correct? x2, I mean, sorry about that. So we'll have the x1 over dt squared equals to 5 dx1 over dt minus, now that is 8x1. Now the sign changes to plus. I hope you know the reason why. Okay, so this is I would call this my equation 4. Let me call that equation 4, right? So with this in mind, what do we do next? Our next step will be step 3 now. What you do, you now want to take this x2 and obtain it from equation 1. Obtain x2 from equation 1. How do you do that? Okay, guys, what you do, you take dx1 over dt equals to 5x1 minus 2x2, right? Now this is same as saying x2 equals to half into, what is that? Guys, I would advise you to pause for a second and get that, and you'll get it as 5x1 minus dx1 over dt. This is your x2, right? Now the next step, which I call step 4, would be to now substitute your x2. Substitute x2 into equation 4. Remember, our equation 4 is this one over here, right? This is our equation 4, correct, right? Yes, now substituting that, you'll have something that looks like dx squared 1 over dt squared equals to 5 dx1 over dt, correct? Yes, that's correct. Now, at this point, what do? We write minus 8 x1, yes. Now plus, remember now x2 is this one, remember, x2. Now, but we obtained our x2 as this. Now what do? We substitute. Doing some substitution, we'll have that into 5x1 minus dx1 over dt. Is that right? That's right so far. So far so good, right? Yes, so far so good. So let's call this our equation. Guys, let's simplify it first. Now simplifying this, we'll have d squared x1 over dt squared, right, equals to 5 dx1 over dt over minus 8x1 plus this one cancels with this, right? If that one cancels with that, then it means we'll be remaining with 5x1 minus dx1 over dt, correct? That's correct. Now simplifying this further, we'll be having something like this. dx1 over d squared equals to, so this one and this one are similar terms. So this means if you minus this, if you take this away from this, you will be remaining with 4x dx1 over dt. Then you have this, and these are similar, right? So that means they're similar terms, which means we have to perform that operation on them, and we have that. Now, I prefer writing this in a very I don't know, I call it a nicer way. So writing this in a nicer way will be something like this, same as x1 double prime, right? 1, right? So I take all these terms to this side, I will have something like minus 4x prime 1, right? Now this will be addition, right? Because it has crossed over to the other side, we'll have 3x1, right, equals to 0, right? So if you look at this equation keenly, you'll notice that this equation is what I call homogeneous, or is what is called homogeneous ODE, right? How do we solve an homogeneous ODE, guys? So let me just put this leaf aside. Put this leaf aside and get another leaf. Get another leaf. So far we were having from the previous section, we were having this as our ODE to be solved. Homogeneous ODE, second order homogeneous ODE, x1 equals to 0. This was our homogeneous ODE. So how do we solve an homogeneous ODE? So our first step is always to form a characteristic equation from the ODE. That will be lambda squared, right, minus 4 lambda plus 3 equals to 0. So the easiest way of solving this is actually to ask yourself which two numbers its product gives you 2 and the sum gives you -4. I would advise you to pause the video for a while, then figure that out. But according to, I can say it's negative product. Is it -1 and -3? Yeah, it's -1 and -3, because the sum of that is -4. The product is 3, right? So if you get these ones, the easiest way, don't go plugging this into this so that you can obtain. Simply just reverse the signs. reverse the signs, and then you have your lambda 1 will be, your lambda 1 will be 3, and your lambda 2 will be 1. Just reverse the signs, it's the same thing, right? So once you have that, you can now form a general equation of the ODE. So the general solution of the ODE that will be written as this. So x1 is supposed to give you e x lambda 1 is that t plus b e lambda 1 is this, so that's t, right? That's correct. Now this is your x1, right? This is the general solution of the ODE. Remember, this is now the general solution of the x1 of the ODE above. Now remember, we had our x2 from somewhere here. Remember when we did this, we had our x2 over here, right? When we found this from our first equation 1, remember? Yeah. Now you take that, which is a half into 5x1 minus dx1 over dt, correct? Now take that and then you now plug in, because you now know what x1 is, you can also find what d of x1 is, what the differential of this x1 is, right? So you can take a half into 5. Remember, x1 is over here, right? So that is a e3t plus b et, right? Raised to 10 minus, now we have to differentiate this to obtain this. How do we differentiate that? So here I'll just do it beside this dx, right? So this is same as having, if you differentiate, okay, a is a constant, right? So e to the power of 3t, how do you differentiate that? Use chain rule, right? So chain rule basically says that if you have the exponent of 3 raised to the power of t, you must. So once, how do you get the differential of this, right? Using chain rule, it states that when you want to get the differential of e raised to the power 3t, remember we're not considering a. Reason being it's a constant. So this would be the differential of this, the whole of this, multiplied by what the whole of this is. Like now differentiate 3t, which is the differentiation of 3t is 3, right? So remember that is a constant, right? Now I'll just multiply that by, what do we get when we differentiate 3t? We get 3, right? 3 you multiply by the whole of that, which is 3 raised to the power of 3t, right? Yes, do the same to this. The differential of e raised to the differential of e of t itself is, okay, b, you'll put it outside because it's a constant. The differential of this is what? The differential of t is 1, right? So 1 multiplied by e et. That should get us at a, okay, 3a e 3t, right? Plus b of et, correct, right? If you have that, you now come and plug that in here, right? That is 3a e 3t added to 3bt, right? Now this will give you, okay, these and these are just kind of same, right? So you'll result with the 2a 3t, right? Then this one and this one are the same terms, which will give you a 4, right? 4, because this is 5bt, right? minus bt because of the sign here. So you have 4b raised to the power of t, e raised to the power of t, right? Now, but remember we have this half. This half, it will affect this one. It will be like that, right? This will be 2b correct, right? That's our x2, right? So remember we have our x1 and x2, right? But then so after we get that, let's write our x1. The general equation of our x1 was this, right? Plus b t, right? And x2 is a e raised to the power 3 plus 2b e raised to the power t, right? So these are the general equations. Yes. Now, the next step after that is now to find the values of. Okay. Now, the easiest thing to do is to find. You can find the. You can just. Okay, guys. So once you reach here, what you do is you. Okay, I want to teach you a very simple technique. Once you reach at this point, what you do, you take x1 and say 1, say a11 e raised to the power 3t plus b. Here, the coefficient of this is 1, the coefficient of this is 2, right? So you take 1, 1, 2, right? E raised to the power of t. So x, it's just x. Now remember you've written both of them. Yes, this is another way of writing it down. So because remember these vectors, if we open the brackets, we're going to get the exact same thing as this side, right? Yes, simple. That's the answer, guys. Thanks for watching.